Alright, so we're looking at related rates of change again, and let's look at this problem. So what we have is that a 5-foot tall woman is walking towards a 20-foot tall street lamp at a rate of 8 feet per second. What we want to do is find the rate of change of her shadow when she is 15 feet away. At what rate is the tip of her shadow moving? So let's say that our 5-foot tall woman is right here, okay? And her height, let's go ahead and let's do a different color for her height. Let's say that she is 5 feet tall, okay? And let's just notice really quick before I draw the other stuff that we've also created a second right triangle here. So we have a second right triangle right here. Alright, so she is 5 feet tall. The street lamp is 20 feet tall. She's 5 feet tall. Okay? And let's just label some of the other things. So we know that this distance, let's call that x, and at time t, so let's call this x of t, we know that she is, let's see, we know that she is 15 feet away. So that's 15 feet. Let's call this y of t, so the length of her shadow at time t, and we don't know what that is. Okay. Also, just for fun, notice that this total distance right here, that's x of t plus y of t. So that's x of t plus y of t. So what that's saying is that at time t, I can add these two distances up, whatever her distance is at time t, whatever this distance is at time t, and get this total distance here. Alright, so let's play with this a little bit. Well, one thing that I've noticed is that this is a right triangle and this is a right triangle, and they have the same angle here, theta. Now, something that we know about similar right triangles is that they're proportionate. That is, if this is 20 feet and this is x plus y feet long, then they're going to have the same proportions as 5 feet to y of t. So that is that 20, its proportion to, and instead of writing this as x of t and y of t, I'm just going to write x and y. Well, that's going to be the same proportion as 5 to y. Now, I don't really like fractions or like formulas with the variables mixed, like x plus y, and then this y on the denominator over here. So what I'm going to do is I'm going to go ahead and I'm just going to cross multiply these guys. So cross multiply, and see if I can get this looking nice, like an actual function should. So if I cross multiply these guys, what I'm going to get is 20y equals, so that's going to be 5 times x plus y. That's going to give us 5x plus 5y. Alright, I'm going to subtract this 5y from both sides. So that's going to give me 15y equals 5x. And those both have a 5 in them, so I can cancel a 5 out of each, and I'll get 3y equals x. Now remember, I wanted to know the rate at which her shadow is changing, and I know that when we're away from the street lamp, this distance, x of t, is changing at a rate of 8 feet per second. So I know, I'll just write this over here, we also know that x prime of t, the rate of change, remember that's what the derivative is 8 feet per second. Now, remember that this isn't just a speed, it's also a velocity, so it needs to have positive or negative with it. Now, since this distance between the woman and the street lamp, since she's walking towards it, what's happening to this distance? Well, it's getting smaller. It's decreasing. So to note that this distance is decreasing, we're going to put a negative on this velocity. So since this distance is decreasing, since this distance is getting smaller as she walks towards it, we're going to put a negative on there. Now what I want to figure out is the rate at which her shadow is changing. So what are we going to have to do? Well, we're going to have to take the derivative of this. So that's going to be 3, the derivative of y. Well, that's going to be y prime of t equals, and the derivative of x, well, that's x prime of t. You can also just write x prime and y prime if you like. So I don't know what y prime is, but I do know what x prime is. It's negative 8 feet per second. So this is going to be 3 times y prime of t equals negative 8 feet per second. Now I can multiply both sides by 1/3. And what I get is that y prime of t equals negative 8/3 feet per second. Great. So that is the rate of change in her shadow when she's 15 feet away. Notice that they gave us the 15 feet and we didn't even end up using it. Now what we want to know is what is the rate at which the tip of her shadow is changing. So the tip of her shadow now. So this distance is changing at a rate of minus 8/3 feet per second. Well, if we just want to know the tip of her shadow, the rate of the tip of her shadow in proportion to this entire length, well, what we can do is we can take this negative 8 feet, that's this rate of change, and then add how her shadow is changing. So the rate at which her shadow is changing is going to be negative 8, that's this change here, and then we're going to add to it the change in which her shadow is changing, and we are going to get negative 32 over 3 feet per second. So we have two answers. We have one that's going to give us the rate at which her entire shadow is changing, and then this one, which is going to tell us just how the tip of her shadow is changing in relation to the light post, which is why we added this rate of change to this rate of change.